The idea is to watch the latest video together, and then we can talk about it, ask questions also.
Browser exploits are very scary. If somebody has a working exploit, simply visiting a website would compromise your machine by installing malware. About a decade ago, this was very common and often referred to as drive-by downloads. Luckily, browsers have gotten a lot more secure, so your typical low-skilled black hat criminal hacker doesn't have this ability anymore. But browser exploits are far from being a thing of the past. They just have gotten a lot more complex and thus expensive. And this can be seen, for example, in hacking competitions like Pwn to Own, where researchers year after year showcase zero-day vulnerabilities they found in browsers and get awarded tens or hundreds of thousands of dollars. Which some say is even low, because selling exploits to, for example, a government would get you 3 or 5 or even more times the money. But why is it so difficult nowadays? I've actually made
So maybe here's a good point to pause it first. This is actually a topic I would like to make another video about. This is this topic of the risk of actually getting exploited, or like getting hacked by a browser exploit for you as a regular person. I remember the times when you visit the wrong website, and just by visiting that website, the pop-ups would start showing up, and you knew, okay, you caught a virus. Your virus scanner maybe alerted you some stuff is going on, but your machine was basically fried. And I was a teenager at this time. I remember, for example, reinstalling the Windows machine from my sister, like a Windows laptop, and I was obviously the tech guy. It was my responsibility to do that for her. So I did that, and I don't remember what site I visited, but once I installed it and I started installing different software for her, I must have gone on a bad website and immediately caught viruses again, and I had to redo the whole machine again, just because I visited the wrong website. So this was very scary, and there is, back then it was kind of cheap. These browser exploits were very cheap. Now, exploiting, like a website exploiting a browser to gain code execution back then was not only the browser's fault, because we used a lot of different plugins. So, for example, Java applets and Flash were the prime, I think, it was a bit before my time, but as far as I kind of remember, those were the prime targets for actual exploit. It was not so much maybe the browser itself. It certainly was too, but it was also these applets. And so they were so common and so easy to find that criminals could bundle them easily into exploit kits and rent them out and sell them for a couple of $100 a month. And you would basically get a little snippet, or you rent, I don't know, a URL from a black hat, and they would basically, you could use that to spread your malware to people that would visit your website. I guess it's still possible today, especially with older vulnerabilities that are public. I mean, vulnerabilities often get public after a short amount of time, but also nowadays browsers are updating so fast that you are probably pretty safe about these exploit kits that might use older free vulnerabilities. So getting actually exploited by a malicious website with an up-to-date browser is very rare and usually reserved for very high-value targets. And you hear about that sometimes in the news about journalists or so. So yeah, it's not a thing of the past. I can guarantee you that there exists, or somebody has a full exploit for the browser you're using right now. It's certainly a guarantee, but it's not accessible to the cheap black hat criminals. They are not operating on and they are not operating on this level. They are like the petty criminals, right? Like, it has to be economically useful for them, and these exploits that are now worth hundreds of thousands, especially when they are operational. Like paying for a bug and a vulnerability in itself is one thing, but then having it fully operational, that it's not crashing the browser, that it's fast, that it's unnoticeable, right? All these things need to be there for a real weaponized exploit. People don't like this term, but so you understand, like an operational exploit, to have it that good that you could use it, that is very expensive, requires a lot of engineering, so it's not really something you need to really worry about anymore. You get what I mean? And yeah, this video talks about one of the reasons, I guess, why, I guess ditching Flash and stuff had maybe a bigger impact than that. But the browser sandbox certainly makes it more difficult, because now you need to chain multiple bugs. And yeah, that's what we will talk about in this video. While we continue watching, I read what you wrote in chat.
Made a short series about the basics of browser exploitation, specifically looking at WebKit, or more precisely JavaScript Core, the JavaScript engine of WebKit. So there you can get an idea how that can look like. But while finding a bug in a JavaScript engine that gives you arbitrary code execution is already crazy and fascinating, nowadays that's only half the battle, because after that you are facing the browser sandbox. And in this video, I want to have a look at the sandbox from Firefox. This video is based on a cool article by Freddy from Mozilla, so definitely check that one out. But let's start with the question, what is a browser sandbox anyway? When you write a simple program and you execute it, it will create a process. And your code can do anything, right? You can write code that open files, write files, or can even start new programs.
So I'm not sure if I got this well across. I was not super happy with the editing of this part. But here I just wanted to show, if you have a program, it can do anything. Like this program is a simple C program, and it opens etc passwd and then just printing it, right? You can compile it and run it, and it can access etc passwd. So it can read it and can print the output. This is the capability of a normal program. And now you can imagine, I want to use this as an example. What if you write a program that has a vulnerability where somebody could, hack it and take over and execute arbitrary code? That arbitrary code has the same capabilities like your program would have. So it would be allowed to read a local file. So I try to make here an example that a program on a desktop operating system at least can do a lot. There's no real protection. On Android and iOS, it's different. The apps are in a sandbox, in an app sandbox, where they cannot easily do other stuff. But on desktop programs like Linux and Windows, a regular program can do everything. So if a hacker can exploit it, get arbitrary code execution, they get the same capabilities and can do everything. Yeah.
So imagine you implement a browser and you have a vulnerability in the HTML renderer or the JavaScript engine. Now an attacker could have arbitrary code execution in your process, and they can do anything your program could do. They could open files, write files, or execute malware. This is bad. And this is how it used to be for browsers. But the architecture of browsers changed over the years. That is the case for every browser. Speaking from a high-level perspective, you can imagine most browsers now to have a privileged parent process that is like your regular process that can do anything, but the actual website rendering, maybe your tab, is another process. And the idea is to restrict this process. Websites with HTML and JavaScript cannot read or write local files, and they cannot execute other programs. So why should this process have this powerful capability? Let's sandbox this process and take away all those features. Then this process can just read HTML, render a page, and execute JavaScript that makes the website fancy.
There is maybe a very basic form of sandboxing you're aware of on, for example, Linux. When you run Nginx or Apache web server or something, they get started as root, right? Like the service, the main service is started as root. But then they create child processes, and these child processes drop their own privileges by changing the user. They are now executed as the www user, I think. I forgot or HTTP user, was it? I forgot. But they get a different user. And this user is not root anymore. So this is a form, a cheap and easy form of sandboxing, because this web server doesn't need root privileges at this point anymore, right? Like they can run as lower privileged processes. And that already, does a lot to hinder like a compromise. I mean, code execution as the web server is still very powerful. You can still usually get all files and all data, but at least you can't really fully compromise the operating system because you are not root. So this is a basic form of sandboxing. But this here goes a step further. We want to really take away all the capabilities of even like handling files and other things. There was also a question if I get annoyed by my voice. No, I'm so used to it, and I like my own videos. So I really like to watch my own videos too. If I wouldn't like them, I wouldn't make them. And when I started out, I made videos and live streams I did not like at all. I really wouldn't want to watch it myself, and that was a sign to me that I need to change how I make my videos. I wanted to make videos that I liked. I mentioned this many times before. I want to make the videos I wish I had when I was a student. So if I don't like watching my own video, I wouldn't like share it. So no, it doesn't bother me. I mean, it was weird, but I'm so used to it now. Oh, www data user. Yeah, correct. It's easy to find my name, but it's like weird to see your real name there. I would appreciate if and understand it's easy to find like this. It's not a secret, but it's weird. It's awkward, right? So please don't. Once you broke out of the sandbox, can you access other tabs? That depends obviously how the process is actually isolated. In terms of Firefox, it's per tab. So now first of all, I'm not a super expert here. This is just educated guesses based on what I think is happening. Okay, I'm not perfectly sure on this. But the tabs are separated. They are separate processes, and you shouldn't be able to access the other process and the data. However, there might be other things that could be possible. And I have seen this being done on Chrome, and Chrome also has site isolation. But now I don't know if that exploit was before or after site isolation existed. But I think Chrome also had per tab. But anyway, there is another technique to access data of other services. Basically, what you can do is, websites are protected by the same origin policy. The reason why one site cannot simply send a GET request to Gmail and pull down all the data, from Gmail is because of the same origin policy. But if you now compromise the renderer process, you can probably change your origin. Either you just navigate away and your code is still running and now you're on Gmail, right? Like this is one option. But you could probably also change the internal security settings where it says this website is not bound to the same origin policy. And I remember on an example, Chrome, I mentioned it in one of the last episodes of the browser exploitation playlist, this example exploit where you break the same origin policy through your exploit. This is a way how you can exploit the initial renderer compromise without a sandbox escape. Because you can then use that to still access other websites' data, and then you are still, can steal all the emails through Gmail, even though you didn't compromise the full browser. And so something like this might work. I'm not sure because I have no clue. This is new topic or unfamiliar areas for me as well. But I could imagine something like this being possible. And maybe this is not possible with site isolation or a fission project from Firefox, because then the processes are separated. But then again, maybe you can still somehow break the same origin policy because now you control the renderer. Yeah, so it's I wouldn't necessarily say that it blocks everything, but yeah, I don't know. These are just some ideas, okay? Like I can't say that it's possible or not, but these are some ideas I would be testing or trying out if I would maybe research or try to exploit things. Let's see. Sorry, questions. I need to scroll up. Can you give me advice? I don't have a study plan. I'm sorry. Check out liveoverflow.com/start-hacking. Or you can just go to liveoverflow.com/start-hacking, and I linked there 2 videos. I don't think alert actually runs in the parent. If you manage to fully exploit the browser, can you... important man, why are you saying this? Like, what makes you think that that is not the case? If you manage to fully exploit the browser, can you execute code as root, or do you need to yet another exploit it? It depends on what the browser is running as. If you start the browser as root, then you run as root. Otherwise, obviously, you need a local privilege escalation as well to elevate to become root. But yeah, most people obviously run the browser not as root or administrator. So then you need an additional exploit for that. I'm saying there is no IPC for alert. Well, we will come to that in the video. As Netherstar said, there is an IPC for alert. It's just not called alert, it's called prompt, but it is the IPC for the alert. But we will get to that in the video, so you will see in a moment. So an attack path would be this one with CSP enforce in Chrome. Okay, you shared some code that we can look at that in a moment. I've not really looked into the code as well. Maybe your question will be answered because this is native code, what you linked here, and the implementation of this IPC is implemented not natively, but in JavaScript. Yeah, but we can search the code in a moment. That could be maybe fun as well. I thought about like tracing where exactly the alert like becomes the IPC instead of just issuing it ourselves, but yeah. I mean, there is a possibility that we are both right, that maybe there is an alert that is not sent through an IPC, that there is, like the regular alert is maybe not one, but there still exists an IPC handler for alerts that you can send to the parent process and get the alert in the parent process. That does exist. So maybe both things are true. You know what I mean? You have hacked on Firefox pretty extensively. Okay, have you checked the article from Freddy then? Yeah, so I would assume then we are both right that the actual like alert in JavaScript doesn't go through the IPC, but there's still an IPC handler for prompts, you know? Freddy from Mozilla is here. Maybe Freddy can answer this. Freddy, I don't know if you joined at the right time, but important man in chat said that alert in JavaScript doesn't lead to an IPC, and now I'm wondering if that's true, that the alert in JavaScript doesn't actually send an IPC, but just that there is an IPC handler to create prompts as well, but that is not really the alert. Could you? Yeah. Okay. Okay, now we kind of go down this rabbit hole already. We are not quite there yet in the video, but we could quickly check here. So this is where the prompt is triggered. Okay. And so what's the different prompt outer, modal prompter? Yeah, I mean, I have no clue about the code. Like, I don't know what the relationship between those two things are. But yeah, what this here, we will see that in a moment in the video as well. This is basically, oh wait, this is JavaScript code, and yeah, okay, no more. Yeah, this is basically what we also see in the video and what we also do by hand. But yeah, okay, so what function is this? Let's see here, okay. If we are in the parent process, we already have a parent actor, we can call its message handler directly. If we are in the content, we'll send a message to the prompt parent window actor. Okay. Important, man, it would still be curious if you say that this here is where an alert is also triggered. Like, I wonder, window. This method is very similar to prompt. Make sure the modifications here don't need to happen over here. Just silently return. Yeah, so I would be curious to know what then the purpose of this code is. But yeah, okay. I have no clue. But yeah, pay attention to chat. Maybe Freddy has some more interesting things to say about it. Let's continue.
And how these restrictions are implemented depend on the operating system. You need kernel features for that. So each operating system does it differently. For example, on Linux, you have seccomp. A process can use seccomp to tell the kernel, please never let me open new files again. And when then an attacker takes over this process, they cannot open files. And when you look...
So this is here where I try to visualize compared to the earlier example code that it's still the same program that wants to open a file and read it, but we are installing here a syscall filter using seccomp.
Process they cannot open.
And when we try to execute it now, the program dies because it's not allowed to execute that syscall. Now, I didn't include the full code here. I obviously just here say enable sandbox, install syscall filter. But basically, to write this code really quick, I went to grep.app and just, what did I search? Did I just search seccomp? There was some example code that I just copied. Somebody had an example code to implement this syscall filter that I just very quickly found through this. And then, yeah, I just installed it. But yeah, maybe it would be a good moment to quickly look that up. How did I seccomp example? I forgot the... it's a bit annoying to set this up. Like, yeah, here. So you create this. You create this filter. It's a big. It's a struct where you can set certain things, and it gets very complex. But you can have very basic filters, such as I want to allow open or not, basically. So it works on a syscall level where you can say these syscalls are allowed or not. And that's obviously a lot more restrictive than, for example, an unprivileged user, because now there are a lot of syscalls you are not allowed to call anymore. And that really, really restricts the process. I have no clue what the Windows version of seccomp would be. I'm sure, so if you saw in the video, they have a wiki where you can read a lot about it. On Windows feature header. So yeah, we can probably just search for these things. Let's see. Okay, that link is broken. But if we just search for something like this, we probably find. So this is the Chromium sandbox, for example. We search for the same flag, and the Chromium sandbox implementation shows up. So see, Chromium uses apparently the same, I mean, it's a Windows feature how to do it, but yeah, you can see that, that they also implement the sandbox in a similar way. I mean, using the same Windows operating system APIs for it. Okay, so we got some update. Okay, regarding the alert. So a quick refresher. Important man in chat said that the alert would not trigger an IPC, and then Freddy said that this is where the JavaScript alert becomes a C++ function. So, okay, I guess. Yeah, I mean, I have no clue how to read this code here. I mean, I don't know. Is that like, I don't know. I don't know. I don't know anything about this. But apparently, this is where the JavaScript alert actually becomes a C++ function call. And then he linked this here. And here's the alert or confirm function initialized using the prompt factory. And the prompt and I guess the modal prompter is, no, this was JavaScript. Okay, this is all very confusing because I mean, the JavaScript code is obviously JavaScript engine is implemented in C++, so eventually a C++ function is called referring to alert, but then I guess it resurfaces again into the parts of Firefox that are implemented in JavaScript, I guess. Yeah, let's continue.
Files. And when you look at the Mozilla wiki about Sandbox, you can find here a config setting to whitelist which syscalls are allowed to be called by the content process, so the Sandbox process handling a website. And of course, there are similar features like this on Windows and Mac OS. This is cool because we can restrict the renderer when handling the potentially malicious website content. But in practice, it's not that easy. For example, the opening, reading, and writing of files. Think about it. The browser wants to cache files and images. Cookie information has to be stored somewhere permanently. When you want to use the file dialog to upload a file, the browser needs access to that. Suddenly you realize, shit, we do need to solve this problem. And this is where IPC, inter-process communication, is introduced. So instead of giving the content process the ability to read and write files, we implement a communication protocol between the two content processes and the parent process, where the content process can only perform well-defined actions. We could, for example, create a message that says, please write this cookie to permanent storage. And then the parent process implements how that is done. The parent process actually opens the file and writes to it. And this is the whole sandbox architecture idea. You have low-privileged renderer or content processes, and they use IPC to communicate with the parent if they want to do anything that would require higher privileges, and let the parent now deal with it. So this brings us back to exploitation again. If you find a vulnerability in HTML or JavaScript, you can take over this process, but you are very restricted. Now you need to find a second vulnerability in the sandbox implementation. Cool. Now we solved one practical problem, but there is another concern you might run into when you want to have an effective sandbox. Let's say all your websites are rendered in this content process and is properly isolated from the underlying system thanks to a secure IPC protocol. Well, many people have their critical data loaded in the browser. Imagine you want to steal a user's email. You don't need malware anymore on the machine. You can simply go to Gmail in the browser. So when you compromise the renderer process and all websites are loaded in the same process, you can now still steal all the emails. So it's still a critical issue when the sandbox process is owned. And this is where we get into a more modern sandbox design, and here you see this visualized in this image on the blog post. Current Firefox, or maybe old Firefox, depending on when you watch this, had a process per tab, and websites can embed other websites through, for example, iframes. So this is exactly the issue we just talked about. But the Fission project for Firefox tries to solve this by implementing site isolation. Now each site gets their own process. And this is awesome because now exploiting the process running this ad cannot access the main page anymore. Your emails on gmail.com would be safe. Of course, this adds more complexity to the sandbox because iframes need to be able to interact with each other. For example, you want to use the post message API in JavaScript to send messages between iframes. So of course, now you need to implement more IPC features to enable communication between those two as well.
By the way, somebody asked if it's the same gray t-shirt. In fact, it's not. This is darker. When I record this, it's a lot darker, so this light gray appears darker. But this is actually a light gray t-shirt, and this is a dark gray t-shirt. But either way, yes, I own the same t-shirts multiple times because I like them. I have two of the light and the dark gray, I think. So it would be no surprise if I would have worn the same one.
So as you can probably guess, this complexity introduced from process isolation can still introduce lots of new vulnerabilities. But the effort is still worth it because now there is an additional barrier where earlier there was none. And as mentioned before, these kind of security features are not unique to Firefox. For example, Chrome also implements process site isolation. But in this video, we want to focus on Firefox. Now, given that Firefox has a sandbox, a full exploit to compromise the machine and install malware requires a renderer exploit, for example in JavaScript, and additionally a sandbox escape. And these two tasks can be perfectly separated.
Here I just need to tell you a little small anecdote from editing. Okay, so you see how I say the full exploit and I list both, on the left side there, and then I say they can be separated. So you cannot animate movements like this in Photoshop. I first edit in Premiere. If I then prepare this text, then I can animate them. But I didn't do that in this case, so I was later editing in Photoshop, and in Photoshop you can only do individual like overlays and you say how long they appear, but you can't say move this to this smoothly. So you have to create movement really frame by frame. So I sat there, and when it showed like both above each other, I thought, okay, let's animate when I say like they can be separated. When I do this, I moved the sandbox vuln thing frame by frame over, and I did not listen 2 seconds longer because then I would have known that it was dumb. But I made this frame by frame animation where this would fly over here, and it took like 5 minutes or so to do this, or more probably, over here, and then I listened to it.
So if you have a team, one person can look for sandboxes.
And then I said on the right side, or like left side here, is sandbox one, but it was on the other side, right? Like it was switched. And then I thought, oh, I'm so dumb. And then I was so lazy that I wouldn't animate it again. Then I did just the cut and it now appears over there. And I was even more lazy because, I didn't reorder it on the left side as well to have it like nicer. But like now we have here this hole here. It just pissed me off so much when I animated this all and then it was the wrong order,
Escape, and the other person can look for the initial JavaScript vulnerability. So as a security researcher, we can choose to hunt exclusively for sandbox bypasses. It will still be useful even if you haven't found a renderer vulnerability yet. And that is also reflected in the Mozilla bug bounty. Mozilla considers a sandbox escape a high-impact vulnerability. Sandbox escapes that assume arbitrary code execution in the content process, such as invoking an IPC method with attacker-controlled parameters, do qualify for highest impact. It is currently even better paid than the code execution in the content process.
Now, this was actually surprising to me. Like, this was not something I ever really thought about or looked at. When I see bug bounties updating their prices or programs, I obviously read them, but it never caught my attention that a sandbox escape is valued higher here than the memory corruption in the renderer. So that was kind of surprising, but as I explained in the video, it kind of makes sense that the sandbox is, at least for Mozilla, it seems to be the more important component where they wanna, they can redirect a little bit where researchers are looking for things by increasing the prices. Yeah. How exactly would one search for sandbox escapes without having taken over the sandbox process? Is there some debug build that enables this? Well, this is exactly what is shown in this video, right? I'm showing how, and it's obviously based on Freddy's article, where he showed how to use Firefox nightly to enable the debugging of the sandbox. And you can very easily do this then in JavaScript, in this case, very comfortable. But again, you can always assume compromise. So in other browsers, or even in Firefox, when you are not interested in these logic bugs, but you want to go a bit of a layer deeper of everything, then you can basically inject your own shell code, right? You could build, Firefox in Chrome, you have sources. So you can build it from sources and you can introduce yourself a basic bug that you can abuse, or you just use a debugger and you just, change the code, inject the code, and you just act as if you had access and then do your research based on that. It's obviously a lot more annoying and time intensive. So that's why I thought this was so cool to see how you could research the sandbox in Firefox using JavaScript. As I mentioned later in the video, there are obviously other ways how you can research the sandbox as well, but it surprised me that there's even this ability to do it in JavaScript only, which I think really lowers the bar for entry for these things, because otherwise it seems so annoying to research a sandbox otherwise. But again, you usually have the sources, so you can really explore the sandbox easily by modifying the code and so forth. Does that make sense?
Which also makes sense. If the sandbox would be perfect, you could maybe even ignore memory corruptions in JavaScript, because the sandbox implementation protects your system.
When I wrote this into the script, I also thought about this more, and I was wondering if the sandbox at some point would get so perfect that browsers don't really care anymore about memory corruptions in the content process or renderer or whatever. And also they would add happily more JavaScript features. So, maybe there will be a world in the future where you readily have available JavaScript exploits for browsers, but they can't do much because now you are in the renderer and the sandbox protects. And then these, but you use these exploits to enhance the browser experience, because now you can obviously send arbitrary IPC messages. So basically, maybe in the future there will be an NPM package like import enhanced API, enhanced browser API or something, which comes with exploits for all the major browsers and gives you an easy API to send different kinds of alert boxes, for example, or something, just because they don't care anymore. So they let it stay in the, they don't fix those issues anymore, and then it will just be readily available as even APIs that websites can use to make even cooler websites,
Okay, so now that we know that the sandbox escapes are interesting, how can we attack them? I'm not an expert, but I think there are 3 strategies. Attacking the operating system implementation, attacking the IPC layer, or logic bugs from using IPC. So maybe you could try to find a bypass or weakness in the sandbox feature of the operating system. For example, if the sandbox is configured to allow unrestricted open and write syscalls, well, then you can write local files, and maybe this means you can bypass the sandbox. Another research angle could be the IPC implementation, which is written in C++. So maybe there are memory corruptions within the IPC protocol layer. And in January, Mozilla even shared a blog post about fuzzing the IPC layer in Firefox. Here, Mozilla even gives tips to hackers. One potential approach to fuzz such scenarios effectively could be to start Firefox with a new tab, navigate to a dummy page, then perform a snapshot of the parent process, and then replace the regular child messages with coverage-guided fuzzing.
Yo, Azibude, thanks for the Twitch Prime. So, I mean, for us in security, this is probably like nothing special that Mozilla would provide educational resources on how you could fuzz Firefox. But maybe my videos get watched by people outside of security, and maybe for them, especially for like regular software vendors, it still seems maybe weird that you would write articles about how to find vulnerabilities better in your own system, right? I think it just shows that browsers are so many steps ahead of how to approach security, also in this term, to try to make it easier for researchers to find vulnerabilities, recognizing that this does not only help the evil people, but that this can actually like improve security overall when good researchers are motivated and the barrier of entry is made easy for them. And obviously this blog post, what this video is based upon, about the IPC layer, this is also one of these blog posts that were written by Freddy from Mozilla to educate people how easy it is to research this in the hopes that somebody, is surprised, oh, I could actually do that, and you maybe spend some time and you have the possibility to actually find something. So yeah, I just like this fact. So hopefully people like more companies recognize that this is a cool way to deal with your software that you develop.
Mozilla wants to share tips like this because if they can help researchers to understand Firefox IPC better, maybe more people can find vulnerabilities and report them. And that makes Firefox ultimately more secure over time. So fuzzing the C++ implementation is another attack possibility. But now we come to the third option. And this is very high level. You will be surprised because you don't really need to have any low-level knowledge to hunt for bugs here. I'm talking about logic bugs in the IPC messages. And this is what this article is about that motivated this video.
Yo, thanks for the gifted sub. I think I have not gotten a gifted sub in like ages. So, or ever. I don't even know if ever. So, thanks about that.
Examining JavaScript inter-process communication in Firefox. Maybe you didn't know this, but not everything in Firefox is written in C++. Actually, many parts are written in JavaScript. Have you ever thought about why the settings page is not some kind of native window with settings, but it's shown here inside the browser? Well, this is a web page that controls the browser settings. By the way, it's the same in Chrome as well. You can even open the developer tools and explore the HTML of this page. You can even see here JavaScript that is loaded from internal resources. By the way, don't get confused by the prefix Chrome. This is not a Chrome conspiracy. I asked Freddy about it and he pointed me to this glossary. In a browser, the Chrome is any visible aspect of a browser aside from the web page themselves. So Chrome is, for example, the Toolbox, the menu bar, tabs. This is not to be confused with the Google Chrome browser. Okay, but in terms of functionality.
Thanks for the dystopia, and I just realized that I'm using Firefox right now, which I wanted to highlight and mention because Freddy is right now here from Mozilla, because we recently met, and it's always embarrassing, to say that I'm using Chrome usually, but I'm very happy right now that I'm actually using Firefox on stream. Always used Firefox as a separate browser to not like mix my private stuff that could be in Chrome with the stuff on stream. So that's why I'm using a separate browser, and that's Firefox. Yeah. Was there anything I want to say about this? Oh yeah, the Chrome thing. Actually, I thought, and it was kind of embarrassing, probably very mad that I even said that. I thought the internal scheme here is Chrome because, I don't know, maybe Firefox uses also the Chrome developer tools or something. But that was probably very wrong, and it was wrong. It's just the name that refers to the layout stuff of the browser. That's just what it's called, so it's a bit confusing. But it's an older term, I guess, that existed way before Google Chrome.
This article introduces the IPC message sender and receivers implemented in JavaScript. They are called JS actors, and they can be used to send messages back and forth. And so let's look at an example.
This is also a first. Holy shit. Die function or defunction. Thanks for 20 subs. Holy shit. This is, I'm a bit stunned. I've never experienced it in the chat. Crazy. Thank you very much. I appreciate it. You are the first person to ever gift more than one sub, I believe. You can container tabs to separate different, maintain separate profiles at the same time in the same window. Yeah, I mean, I use profiles in Chrome as well. And each profile is just a different user and purpose and stuff like this. So I don't feel like I need that on the tab level. I think that would be way too complex to manage. I like that it's separate windows, and each window is like one user, one domain, one thing. So I can then also quickly switch, the profile windows in Chrome in the settings up in the top right and stuff. So, but I don't want to talk. I guess the tab feature is good, but to be honest, I think that's way too micromanaging for me, I think. But I also don't know how it's implemented, so maybe I should check it out first before I say something dumb. Maybe it's cool. I don't even know how to use it. Is it maybe not in this Firefox version yet? How it's implemented really well. What happened to my fingers? Yeah, people have noticed that I have here tape on my fingers. What happened was that I have a mobile AC unit, right? And you need the host to go outside the window, but I don't have proper windows where I can easily put that outside and seal it off. So I bought a huge sheet of acrylic glass, and I drilled a hole in it and glued the hose into it so that I have like a replacement window that I can put into the window frame to then have the hose going outside and it's sealed off. And these edges of this glass are very sharp, and I just cut myself like 3 fingers when like I tried to carry the acrylic glass. That's what happened. I just realized we have a level 5 hype train. Okay, not very hypey music. It actually didn't hurt. I actually didn't notice it. I just realized that I'm bleeding, and I thought I should probably put tape on, not that I infected or something when I like touch food or something. I don't know. Okay.
To prepare the browser.
Okay, so wait, we need to go back. I accidentally skipped forward. Okay.
This article introduces the IPC message sender and receivers implemented in JavaScript. They are called JS actors, and they can be...
Oh, carton. I just noted the 500 bits. So, okay, now it's getting too much. Like I worry I miss people now, but I appreciate it. That is a luxury problem I never had before.
Used to send messages back and forth. And so let's look at an example. When you execute alert, this overlay window is opened, and this is actually implemented in the parent process. When you execute alert 1 internally, an IPC message is sent from the content process to the parent. Please open an alert box. And this alert box has a title with the URL, the text we entered, and an OK button. So now let's investigate this. I'm using here Firefox nightly, and any of these steps we are doing could change anytime, but I'm sure it will be similar or there will be updated guides.
Thanks, Kronos, now for the sub as well. Okay, sorry. Like these are new chat things that I've never seen before. You got a level 5 hype train emote. I can share it. Cool. Did that do anything? Weird.
To prepare the browser for research now, in the DevTools we have to go to the settings and enable browser Chrome debugging toolboxes, and we enable remote debugging. And then you have to restart Firefox nightly. Once restarted, you can now go into the menu, Tools, and open the browser toolbox. This opens this multi-process browser toolbox, and it's basically an attached debugger for Firefox, for the parts that are implemented in HTML and JavaScript. And we are right now in the main parent thread. And you can see here other processes. For example, a process for browser extensions, which are isolated as well, having the process ID 35016. And as I said, many parts in Firefox are implemented in HTML and JavaScript. So the interface, see this, we can explore the browser interface. We can even look closely at the implementation of the tabs. Here's the liveoverflow tab, and I can even modify the interface. It works the same way how you can use the DevTools to modify websites. I mean, this literally is the familiar developer tool. Anyway, we are interested in the IPC mechanism. So we can now look for the message handler for the alert box. We can search for the message prompt open, and we can find this receive message function. So let's set a breakpoint here and call alert again. Alert test. Browser freezes, and in the toolbox we can see paused on breakpoint.
So earlier somebody said that alert wouldn't send an IPC, and then somebody else reminded me that I did type in alert and I got the breakpoint that should have already proved to me that, yeah, we did indeed send an IPC. This was like, I mean, this is the proof of it, but I've totally forgot I did that.
We are in the main thread in this function. So let's look at this IPC message coming in. It, for example, has an args.title with the URL or an args.text with the test string. There's also a modal type, which is currently set to 1, and it seems to control what kind of alert box you get. Pretty interesting, right? You could now change here values and see what happens. But this is just...
Yeah, so now you have the IPC message coming in, and you could start debugging this. You could step through, you could go into these other functions that are being called. You can obviously use the DevTools down here to change all the values. But of course, this is more about like understanding what the handler really does. Just because you change something doesn't mean you can actually control it from the IPC sender, though I think the message data is fully like controlled by the sender. So anything that comes into this function as message.data is definitely controlled by the content process sending data in. So you can like really debug. You can read this code now, this JavaScript code. You can step through it. You can debug it. And you can think about, okay, what if this message data field is a different value? It's an object. It's something else. Does it cause anything weird or interesting to happen in the code? And yeah. So that's what you could so easily do now. I guess the bigger challenge is like finding all the receive handlers and stuff, but I guess if you have done it like 2 or 3 times, looking up the different receive handlers, you can find them. But yeah, it's really comfortable to debug this code now.
That's the receiver side. Let's look at the sender now. The content process sending this IPC to the parent. To do this, we open another debug toolbox, this time the content toolbox.
That's a good one. It's an irony that the internals of the browser are clearer to understand than websites with their minified JavaScript. Yeah, that's a good one.
As you can see, it is running in another process 25072, the web process. And this basically has the capabilities you have when you would have compromised the content process. Here we can, for example, access the tabs and get the first tab pointing to liveoverflow. And now we just need to follow basic instructions how the IPC protocol works. First, we want to get an actor for the prompt and then send a query asking for the parent to please open a prompt with these parameters.
Yeah, so this is just, it's explained in the article about this, like how this IPC messaging works. It's not something generic. This is something like that Firefox implemented. They implemented their IPC this way. So you just need to know how to use the IPC, and it works by getting a certain actor in a certain like namespace. Like there's a prompt actor now, and then you can send a query with this data that you can see here. So yeah, that's just, you know, if you're confused, like how do you come up with this? This is just the way how it's implemented. You just need to know this. You can see that in their own code, or as I said, like Freddie shared it in their blog post. So yeah, this is just how you have to call it.
And we can play now with these parameters. For example, we can specify a different title or change the modal type to 3 and even fake this remote ID.
Yeah, here when I saw this, the first time when I did the example from the blog post, I thought, oh, remote ID, maybe that is something like very special. Maybe the remote ID says which origin was it really, and could you mess with the origin and then something would happen or something. I don't know, whatever. So yeah, like these are the thoughts and ideas you need to have, and then you can test them and you can debug and verify if your idea was right or wrong.
Let's see what happens. Okay, breakpoint hit in the parent, and here you can see the fake data coming in. We were really able to control this data.
That's a good question, Coco. How does the browser prevent you from sending these IPC messages from normal JavaScript? Well, normal JavaScript just lives in a completely different world. When your browser, when you have JavaScript on a website, you know, a JavaScript engine will take that JavaScript code and interpret it and execute it. And that JavaScript code has just certain functions and objects available. You have the DOM, for example, where you can access the website and so forth. But that lives in its own thing. This IPC is a complete separate thing. It's not the same JavaScript. These worlds have nothing to do with each other. That's why. But they are still in the same process. But from JavaScript, they are just like two different JavaScript worlds. That's why you need to break out of this JavaScript world through a memory corruption in the JavaScript engine, for example. Now you can, now you have access to the whole process, and then you can also send these IPCs. That's why you need this first exploit to send these arbitrary IPCs. But just from the JavaScript world itself, they are completely separate. They have nothing to do with each other. You cannot do anything. I guess I'm not. So if you watched I have this browser exploitation video series, and there we go into a renderer exploit in WebKit. So WebKit is a different browser. It's obviously in a browser engine. It's different from Firefox, but the principles are kind of the same. And for example, for WebKit, it was this way that you have JavaScript code and you have an interpreter. This interpreter takes the JavaScript code and parses the JavaScript code and make like a tree internal structure of how the code is represented, and then it goes like through it and evaluates everything. But then you also have JIT, just-in-time compilation, where pieces of JavaScript are compiled to optimized code, even down to raw assembly code that can then be executed. And let's say you call alert from within JavaScript. The JavaScript engine comes to the code where you wrote alert, and basically the JavaScript engine then says, oh, we need to call alert. And now it will send an IPC over. So like you are living on this very different world and layer, right? Your code is being interpreted by something, and that sees you want to call alert, and that then sends for you the IPC. You never send the IPC directly yourself. Does that make sense? Yeah.
Let's run it and see if the model type 3 looks different from the regular alert. Look at this. Model type 3 is a weird native window, not this fancy overlay window. Kind of looks like an old school alert. And you just witnessed what a compromised content process could do. You cannot do this from regular JavaScript on a website, but if you find a vulnerability in the
No, the interpret layer is not JavaScript. The interpreter is, like, I don't know how it is for Firefox, but I would also assume it's written in C++ or something. Like the JavaScript engine has to be really fast. It's probably implemented in C++. This C++ code can interpret JavaScript, and when you write in JavaScript an alert, the C++ code knows what to do with that and will then call the IPC. But now we come in the special world of Firefox where, you know, the IPC is sent maybe through JavaScript. So maybe and this is, as Freddie mentioned it earlier, it's probably getting very complex how these worlds like are connected actually, and they might be prone to bugs, right? Because that seems complex. You come out of the JavaScript world, interpreter into the C++ world where then something else executes, and that goes back into another JavaScript world or something, you know, that sounds all scary, kind of. But it makes sense to have, as Freddie also mentioned earlier, it makes sense to have these debugger and a lot of stuff implemented in JavaScript and HTML and CSS, because then it's much easier to develop for those things. And also, if you are able to kind of secure that well, then you can now write in higher level languages like JavaScript, and you won't have a memory corruption in the JavaScript anymore. Right now you have logic bugs, but that might be, I mean, you also have in C++ logic bugs, but you now do not have memory corruptions anymore. And yeah.
Content process, you could send arbitrary IPC messages, like we did with the debugger toolbox. So you can now hunt for logic bugs. For example, looking for IPC message receivers that handle files, for example, and you could try to send evil arguments that maybe breaks something. In our example, we could maybe, instead of strings, send a JavaScript object and try prototype pollution. So I create an evil object with just some messy stuff and send that. We get an error that it's an unknown dialog type object, but nothing else seems to have broken. But you get the idea. You can use the browser toolbox to explore the IPC and look for logic bugs. The article also shows an example of such a sandbox escape, CVE 2019-11708. This vulnerability was used in a zero-day attack against Coinbase in 2019. Read this. Insufficient vetting of parameters passed with the prompt open IPC message between child and parent process can result in non-sandbox parent process opening web content chosen by a compromised child process.
I think that is so cool, right? Like, we looked at this prompt open handler just a moment ago, where we saw that this is how the alert box is implemented, and you send this IPC and an alert box opens up. Who would have thought that in that code there used to be a vulnerability to break out of the sandbox? And this description here is now also understandable, right? It doesn't check the parameters well for the data you sent in with the IPC message. You send prompt open to the parent, and in that case, there was a weird like implementation detail for prompts. There was not just alert boxes, but you could open a URL, and that would then lead to that URL being rendered in the parent process that is not sandboxed. And I guess you would now have, like, you need an exploit to get into the renderer. This renderer then sends an IPC, this prompt open IPC, to open the URL in the parent, so they can kind of like open the same exploit again in the parent and then probably do the same exploit again, but now they are in a non-sandboxed process where they have code execution. That's how they escape the sandbox. Oh, .cs, thanks for the Twitch Prime.
So, as we just learned, web pages are opened in this isolated sandbox process, and only privileged and trusted internal sites, like the settings page, is opened in the unsandboxed parent. But the vulnerability here was that the prompt IPC handler could be abused to open a prompt as a new tab loading an attacker-controlled website in the parent process. And this attacker-controlled website is now not restricted by the sandbox anymore and can thus do much more privileged actions, eventually gaining code execution on the machine. Sandbox escapes can...
Yeah, we can also maybe have a quick look into the article, because Freddy showed here the code that basically the fix of this 0 day. So here's the diff between the vulnerable and the not vulnerable, the vulnerable and the fixed version. And this is what you have seen or right now, right? Here's the receive message handler, and here you can see the message data coming in with the arguments, and there's a browsing context. And you can see here that in this switch case, which we had, let's see. Here, this is like this code here, right? This code, but this is the fixed version. So you have here this, it checks if the message is prompt open, and then it checks, for example, here the modal types, and then opens different things. Yeah, we can see here that the modal type could lead to, for example, is about add-ons option page, or open content prompt, or open prompt with tab dialog box. So there are a lot of different things that the prompt open can open. And back then there was a tab prompt that would open a new tab, and the args data had a parameter called URI, so you could open just like directly a different website as a tab, and that would be then a privileged tab in the parent. At least that's how I understand this code here. Is Sandbox escaping something that can be detected by EDRs? Easier to detect the payload that comes after the Sandbox escape when the attacker spawns a process. I think the Coinbase blog post, they gave a tiny clue how they did it. Yeah, I don't know how EDRs work. Like, it's always like best effort. You just hope you have certain things to detect. But obviously, spawning processes, like spawning malware, that's, I guess, always the strategy for these things. And so if you have malware that, or if you have an exploit that then creates a new process to do things, that could be detected. But I guess the Sandbox escape itself, then EDR wouldn't have any knowledge about like what is a legit IPC message. Like, they don't understand this world of IPCs probably. So, not properly, they don't. It's just like, yeah, I don't think they could detect that. Maybe they could detect, no, not even that. I was just saying maybe they detect if the exploit would map some executable memory, but the browsers are jittered anyway, so they have executable and writable memory and all that stuff. So, yeah, difficult. I don't know. No experience with that. Thanks, Ruma. Okay, so we are almost done here.
independent by the sandbox anymore and can thus do much more privileged actions, eventually gaining code execution on the machine. Sandbox escapes can sound really complicated and magical, but I think this blog post was just excellent to show you how easy researching the Firefox sandbox could be. Really cool. I hope this overview and a short dive into the Firefox sandbox implementation was interesting to you. If you want to learn more about browser exploitation, check out my playlist that I mentioned before, and of course check the description for links to the articles.
Yeah, so at this point I can only say I didn't even add it to the description. I'm such a good YouTuber. I have this browser exploitation playlist where I go
free video series
into a WebKit exploit. Things have changed in WebKit since then. There were some hardening things that make this technique shown here not possible like that anymore. But yeah, if you want to get an idea how browser exploitation, like the renderer exploitation part, looks like. Now you have so you can watch that in the series, and now you have the sandbox video where you can understand the second part, like what happens once you have this initial exploit. What can you do? How could a sandbox escape looks like? Obviously, completely different browsers here, but just for developing an intuition and an abstract understanding how these things work, I hope that. That can help. I also just realized I added here a video from Andreas Kling, which I completely forgot about, but I watched it and I thought that would be a good match for the series, so I just added it into the playlist. Andreas Kling is the developer of Serenity OS. I made a few videos covering Serenity OS as well, and he's also, or they are working on a browser, and this browser also tries to implement JavaScript, and it's very difficult to implement JavaScript. So their browser also had memory corruption issue, and in this case an integer overflow in JavaScript type arrays, and so he is writing an exploit for his own browser and so forth. So while obviously this is not, you know, a real browser like Firefox or Chrome or so, it's obviously a not used browser in quotation marks, but it still makes you really better understand the internals of JavaScript and so forth. So I think that's a great video as well. Let me just post this link in here. That link will get you to the playlist and to this particular video as well. Okay. Now, thanks for watching with me in this video. I'm very happy about this video. I really like it. I think it's a video because what are sandbox? I remember those are questions that I didn't quite understand, and I think this video can provide a good feeling for what a browser sandbox is and so forth. And so I like this video myself, and yeah, I'm glad that people like it as well. It's performing pretty well compared to, for example, the pseudo videos. Now, what's next? Maybe people have already noticed here other tabs up here in the browser. So let's move on.